Today I'm going to show you what happens to the pressures on your gauges when we have a blower motor failure on the unit inside. Now right now I have the system running normally, it's stable, my pressures are settled in right where they need to be, and we're going to go ahead and turn the blower motor off and see what happens to our pressures. Now to do that, I hooked up a second thermostat to the unit inside that is connected to a rib relay, and that rib relay is going to interrupt the neutral wire on my blower motor. That gives me the ability to control the blower remotely from out here by the unit. So we're going to shut that blower down. We're going to watch our pressures change. We'll restore the blower, watch our pressures go back and normalize, and then we'll talk about what's actually happening. Now, before I shut this blower down, I'm going to keep an eye on two things here. One is going to be the amperage reading on the compressor itself, so we can keep an eye on that. The other is going to be the temperature on my suction line, and that's going to give me my superheat reading. Now that's going to be very important, and I'm going to explain why in just a few minutes. But let's go ahead and shut this blower down, see what happens. So as you can see, that pressure on the blue gauge, our suction pressure, is dropping pretty hard. Now that temperature in the corner, that is the temperature of the suction line, the copper line. And that temperature is dropping right along with it. Our head pressure on the red gauge, that's also dropping, although not as quickly, but it is dropping like everything else. That temperature on the suction line is going to keep dropping and go below the actual freezing point of water. And at that point, we can actually have frosting start to develop on the suction line. So I'm going to go ahead, I'm going to restart this blower, and you can see as the blower kicks in, the temperatures and the pressures, they immediately start to recover, and they slowly work their way back up to temperatures and pressures of a normally operating system. So we have a low suction pressure, we have a dropping head pressure, we have frosting lines. These are all classic signs of an undercharged system. Now a lot of technicians, they'll see that and they'll start dumping refrigerant in there. But there's one temperature I told you earlier that was really important. That was my superheat reading. That one reading is telling me the difference between an undercharged system and an airflow issue. That superheat reading is telling us the entire story behind what's actually going on here. When a metering device injects liquid into the evaporator coil, it's the blower motor blowing warm air from inside the home over that coil, and that warm air boils off the refrigerant into a vapor, just like pot of water on a stove is turned into steam by applying a flame to it. Now about midway through the coil, the heat from the blower starts to increase the temperature of that vapor refrigerant, and that's the temperature we're measuring outside on our copper line. In a situation where we have an undercharged system, the metering device is not delivering enough refrigerant into the evaporator coil, so we end up with a very small amount of liquid refrigerant. Meanwhile, the blower continues sending heat into the refrigerant, so that refrigerant turns into a vapor much sooner in the coil. That means that vapor refrigerant has more time to pick up heat as it travels through the remainder of the coil to the outdoor unit. That means the temperature of our line will start to increase, which will increase our superheat reading. With an airflow problem, however, it is the exact opposite. Our metering device is properly administering liquid into the evaporator coil, but we don't have the heat there to boil it off into a vapor because our blower is not delivering it. And so what happens is that liquid refrigerant stays liquid longer, and eventually it makes its way all the way to the coil, all the way outside to the compressor, and we can end up slugging our compressor. And because it remains a liquid, it never increases in temperature. So our superheat value starts to shrink down more and more and more until it eventually reaches zero. This is why more experienced technicians always check airflow long before they start diagnosing with their pressure gauges, because as we've seen, airflow can have drastic effects on it. Matter of fact, even changing your blower speed can change the pressures on your gauges. Now if you guys find this stuff helpful, hit the like button, drop a comment, let me know. Hopefully I'll see you next one.